welcome to my channel KM Solution. Today the most important topic for the revision is titration. So we will start today titration, the quick revision in titration, so you can score good marks in titration. Clear? So let's start titration. First of all, titration, what do you mean by titration? There are two solutions, a known solution and known solution. Clear? So if you have to find out the molarity concentration of unknown solution with the help of known solution, the process will be known as titration. Clear? In your course, redox titration is there, in which oxidation and reduction, both of them take place simultaneously. Okay, so titration is also known as volumetric analysis. It can asked by the examiner in the questions, Viva questions. It is the field of analytical chemistry. One more thing about titration is there are two points, titrant and analyte. Okay, so what is titrant? Titrant with a known concentration, which concentration is known, whose concentration is known as titrant, and whose concentration unknown is known as analyte. This both definition you should remember in the exam. Next point is end point. You can see here the color of the solution will be light pink. Okay, this will be the end point. Clear, guys? Next we can say let's some points about KMnO4. KMnO4 potassium permanganate. It is purple color solution. Okay, crystalline solution. You have to read the upper meniscus of burette in the KMnO4. You will fill KMnO4 in burette. Okay, it is a purple color solution, and you will read upper meniscus. There are like two meniscus like this, like this. So the upper meniscus you will read because it is the colored solution. In the case of colorless solution, which you will take in the pipette, that is of ferrous ammonium sulfate or oxalic acid, so you have to read their lower meniscus. Remember this. Okay, next point, it is a strong oxidizing agent, which KMnO4 in acidic medium. Remember, this is the important point. It is a strong oxidizing agent in acidic medium. Okay, so it also acts as an indicator, also self indicator also. Now with the titration with the ferrous ammonium sulfate, KMnO4, there are three acidic medium present. You can add dilute H2SO4. Okay, if examiner can ask, you can add dilute HCl in ferrous ammonium sulfate, then it will be not recommended because it will react with KMnO4 and the reading will be high. And next, HNO3 also cannot be used because it is also oxidizing agent. The reading will be less, so it cannot be used. So in ferrous ammonium sulfate, acidic medium as dilute H2SO4, one test tube will be required in ferrous ammonium sulfate with the titration of KMnO4. Clear? KMnO4, most important point, it is also known as secondary standard solution. Secondary standard solution. Why? This you have to remember. This is important point. This is secondary standard solution. Why? Because its molarity and its concentration, and strength does not remains constant. It changes. When we make KMnO4, after some time, its strength and its molarity changes. It is highly reactive. That's why it is highly reactive. It reacts with air, impurities, and its strength will change. Clear, guys? So this is the good point about KMnO4. Next, that's why in the aim, molarity and strength of KMnO4 is asked because it changes rapidly. Okay, now second point, more salt ferrous ammonium sulfate in oxalic acid is also called as secondary standard solution. Sorry, it also called as primary standard solution. Secondary standard solution is the that your secondary standard solution is KMnO4. Okay, it is known as primary standard solution. Primary standard solution, because after making m by 20, m by 30, m by 40 type of concentration of more salt or oxalic acid, it will remain, this concentration and molarity remains the same. That's why it is known as primary standard solution. Clear? Next point, we have to do the titration with the two. Number one is more salt, whose formula is FeSO4.NH4 SO4.6H2O. It is known as double salt. Very important point, double salt. Okay, why it is known as double salt? Because there are two cations present. One is this and another one is this. Clear? It is light green in color. Because why it is light green in color? Because of transition metal Fe is present in it. You know, transition metals show color. Clear? And this is a hydrated form. 6H2O is present. 6 molecules of water is present. That is all about more salt, and the molecular weight of more salt will be 392 kg. Okay, atomic mass unit. Clear? You have to add H2SO4 2 ml or 1 test tube of H2SO4 in ferrous ammonium sulfate to prevent the hydrolysis of ferrous Fe2 plus ion. You have seen that in the titration sometimes brown color appear. Okay, so if to decolorize that brown color, you have to add, to prevent hydrolysis, you have to add the H2SO4 solution. Here guys, next is oxalic acid. The formula of oxalic acid is COH.2H2O. It is diabasic because 2H plus ion are there. 2H plus ions are there. Clear? Molecular weight, don't forget the molecular weight, with water 126 and without water with 90. Okay, this is the oxalic acid. About oxalic acid, one more thing you have to remember about the oxalic acid, that you have to heat the oxalic acid before the titration. You have to heat the oxalic acid. Why? The reason I will tell you that it is a slow reaction. To speed up the reaction, you have to add you have to heat the reaction, heat the oxalic acid at 60 to 70 degrees C. Okay, to speed up the reaction. Clear? Now coming up to the calculation part, the part of more salt calculation, which will be with formula M1V1 is equal to M2V2. Now this is the whole ionic reaction. Clear? 1 mole is here and 5 mole of iron is here. This is the acidic medium. Okay, so 1 mole and is equal to 5 mole. Okay, this will be the formula. M1 will be the molarity that is given in the question, m by 20, m by 30, whatever is given in the question. Next one, V1 will be your 20 ml, which you have taken in pipette. Okay, M2 will be, you have to find out a molarity of unknown, and V2 will be your concord reading, what reading you are getting the same at the last of the titration, that is known as concord reading. You have to put in it and do the calculation and calculate the molarity. You have to remember, after 0, the dot after 4 decimals you should take, and the symbol will be M for molarity. Clear? This is for more salt. Next one, for calculation of oxalic acid, you have seen here also acidic medium is there, 2 moles and 5 moles, because it is a weak organic acid. It is a weak organic acid. That's why there are acidic medium is also taken. The formula will be 2m1v1 is equal to 5m2v2. 2 moles here and 5 moles are here. There is the row here. You can write 60 to 70 degree C. You have to first heat it to because the reaction is slow, so to speed up the reaction you have to heat at 60 to 70 degree C. Now one more important thing is role of Mn2 plus. Okay, this Mn2 plus is forming, so it acts as a auto catalyst. Very important point. You have heaten the oxalic acid and start titrating, the rate of reaction increases. Okay, after the formation of Mn2 plus, it acts as an auto catalyst and the reaction will be continuous after the Mn2 plus formation. So this is the important point about oxalic acid. Now talking about the strength. If strength is asked in the question, then what will you calculate? How will you calculate? You have to calculate molarity into molecular mass. Molecular mass 158 of KMnO4 you have to take. Remember that, and it will be in gram per liter. Okay, strength in gram per liter. Next question is percentage purity. It is also asked in the question, percentage purity. What is the formula? The strength upon whatever the weight is given in the question into 100. That will be the percentage purity. So this is the formulas of your both ferrous ammonium sulfate and oxalic acid. Next, talking about the precaution part, very important part. It will be asked in the exam. First of all, clean all the apparatus with distilled water before starting the experiment and rinse with the solution to be taken in them. Whatever solution you are using, ferrous ammonium sulfate, rinse that, rinse the flask or apparatus with that solution only, because water can be remain in there. So उसी से साफ करना है आपको, उसी सॉल्यूशन से साफ करना है जिस सॉल्यूशन से आप यूज़ कर रहे हो. Clear? Rinse the pipette and burette before use. Potassium permanganate is dark in color, so always read the upper meniscus. That I have told earlier. Use dilute sulfuric acid for acidifying the potassium permanganate. I have taken dilute sulfuric acid H2SO4. You cannot use HCl and HNO3. The reason I have told you. Second, take accurate reading once it reach the end point. End point when the light pink color will be appear, and don't go with the average reading. If reading is not coming, you have to drop by drop add the solution. Next, do not use the rubber cork burette as it can be attacked by KMnO4. You cannot use the rubber cork in the pipette. So these are the precautions you have to remember. Okay. Last but not the least, you have to remove the funnel while doing the titration, because your examiner will definitely check that and deduct your mass. So this is all about titration. Please like and subscribe my channel. Thank you and have a nice day. Bye.